Hi everyone. Today I'm going to go through the multiple choice solutions to the Specialist Maths, QCAA Specialist Maths Paper 2, just the multi-choices, and this is the mock assessment from 2020. So first thing to note, you have 70 marks to achieve in 90 minutes. A quick calculation will show you that you get about 1 minute 15 seconds approximately per mark if you want to budget your time according to the number of marks. This is a very rough guide. I'm going to try to achieve about a minute per question. Each of these multi-choice is a minute. If you can knock over the multi-choice in somewhere between 10 and 15 minutes, then you're pretty much on track. So let's see how we go. Now, first question. The time between calls at a call centre is assumed to be a random variable x with an exponential distribution, and this is the density function which we have studied. They tell us that the mean is 1 over lambda. That's a fact that we probably should have known as well, but they were nice to tell us that. The average worker receives a phone call every 15 seconds. That's the mean. So this tells us straight away that lambda is 1 over 15. Now I did a little bit of writing down here. Don't be afraid to write on the question paper. This bit doesn't get reviewed. Just make sure that you transfer your answer onto the bubble chart. So do a little bit of writing. Now here is what I would have been doing on my calculator. Straight away I would have gone, well, lambda is 1 over 15, so I'm going to calculate 1 over 15, and I'm going to store that, and I'll just store that in variable A. They wanted to know the probability of a worker here waiting between 1 and 2 minutes. So remember to change to seconds, and this is the integral I need to perform. Now, I can do that on my calculator. If I go maths, then integral. So I've already got lambda stored. So I'll just go A. E to the power of negative AX from 60 seconds to 120. And there's my probability. Now, which of these answers is closest? It's option B. Let's move on. Question 2. Given that the complex number z is pi cis pi over 7, the real part of z cubed is. Now again, I wrote this down simply to explain to my students, but when we have polar form, we cube the modulus and we multiply the argument by 3. And cis literally means pi cubed by the cosine of the angle plus I times pi cubed by sine of the angle. The real part is this. So I simply plug that into my calculator. I'll need pi cubed, then cosine. Just check on my radians, that's a classic mistake, and it's 3 pi over 7. Oops, didn't mean to do that, meant to go down. 3 pi over 7 gives me close enough to 6.9. That's option A. Don't worry about the imaginary part, it wanted the real part. Question 3. An object travels along an elliptical path described by this position vector r. Note the bold type means that that's a vector. This is a parametric equation. T usually represents a time parameter. This is a classic for the calculator. Pop into the graphing app. Most of the time in the graphing app, we will be in functions, y equals. But we can change the type of graph here with F3 to parametric graphs. Oh, those ones are still there. Well, I should have probably deleted those. If I reset my calculator before the exam, then none of that would have been there. So, in a parametric equation, we get to type in the formula for x and the formula for y. This bit here is the function that describes how the x coordinate of the particle changes with time. So that's the bit that I'll put here, 3 cosine 5t. And when you're in parametrics, this key automatically enters t as a time parameter. Then 2 sine 5t for the y value. Let's draw that. Oh, that's a bit big. We could always change the view window to the initial setting. And that's a lovely little, it's an ellipse. Now they told us that it was an ellipse. Fine. The initial position and direction of the object. This is where we use the trace function. We can see the marker appeared here, and t is 0. I've got derivatives turned on. Who cares about them at the moment? When t equals 0, that gives me the initial position, and that's a coordinate 3, 0. So it's got to be either choice C or choice D. Now, if I just hit the right arrow, time advances a little bit. So time is moving forwards, and you can see the position on the trace function is updating. The particle is moving in an anti-clockwise direction. So choice D is the one to pick. Question 4. Oops, I scrunched my calculator a bit. Oh, now I broke the calculator. Okay, question number 4. This matrix represents the win-loss for a netball competition. It's a dominance matrix question. Which of these dominance matrix calculations could be used to determine an individual rank order of the teams from 1st to 5th? So I do not want to be typing a 5x5 matrix multiple times to check all of these. This is exactly why we can store matrices in the calculator. So let's just clear all of that. Now, matrices and vectors. I'll just go straight to the first one. Matrix A, dimensions need to be 5 by 5. Excuse me. And now I need to, where is it? There it is. I need to have these. So for the first one, we have a 1 here in column 2. The others are zeros. I'll just use the right arrow to advance. Now I need a 1. And a 1 in column 3 and column 4. Third row, we have a 1 in the first location, and in column 4 is a 1, and column 5 is a 1. Now, it's worth being a little bit careful when entering, because of course any mistake here will follow through the entire question. And then the last row, we have a 1 in the first and the second column, and the rest are zeros. So that's the matrix entered. Let's pop out of there. Now, when we're doing these, I'm also going to dimension matrix B as a 5 by 1 matrix, and they're all going to be 1s. And this is a handy little trick that will help us in a minute. So let's just pop back over there. Now, the first choice for this thing is n plus n squared. Well, we called it A, didn't we? Now I have to get to where the matrices are stored. So I'll have to go options, matrices, matrix, A, plus, and then I want matrix A squared, matrix A squared. And when I enter that, I get a 5 by 5 matrix, of course. What I really want to know is I want to add across each of these rows, don't I? So that first team would have had 3 wins, and then 2 plus 1 is 3, plus 4 is 7. Now there's a quick way to do this. I'll put a pair of brackets around all of that, and then I will multiply by matrix B, or not log, by matrix, oh, I did it again, matrix B, get it right this time. That was that column matrix which were all 1s. The effect of that is to add the rows and write it as a column matrix. So for choice A, you can see it's there. I wrote it down, 3, 7, 8, 5, 5. Now this is not going to give us a unique rank order, because these two teams here both ended up on 5 points. I know that seemed like a lot of messing around, but trust me, Now that we're back to this one, all I have to do to check choice B is go back here and put 0.5 times. And I straight away get the second one. It's not unique, there's two 3.5s. So I can go back. It's a little bit of time to set it up, but it's a much quicker than entering a 5 by 5 matrix over and over again. So I need n plus n cubed. So I'll just change the exponent to 3, 6, 10, 11, 7, 9. Yes, all of those entries are different. There is a unique outcome for each team. That would be a viable choice. And just to be on the safe side, I'll check the final one. So what I will need here is, just to be on the safe side, I'll use some brackets around that one. So it's n squared plus n cubed. And there's the result. There's a couple of 13s. Sorry about that. It's not unique. So C is the choice. Definitely quicker to do the matrix, enter the matrix in the calculator. For this one, an object is a mass of 450, travels in a straight line, displacement x over time. X is given by this equation. And we want momentum. So we need to recall momentum is mass times velocity. Velocity is derivative of location, derivative of x, dx dt. Derivative of this, well, that is minus 1 over 15 is considered a constant, so it can come to the front. Derivative of 20 is nothing. Derivative of this is negative 3, so that's that. And then you simply plug it into your calculator. I'm not going to waste your time showing you that one. This is a nice one. Area of an isosceles triangle. So the sides are of length A. The included angle theta is, here's the formula for the area of the triangle. They tell me that the included angle is increasing at the rate of pi over 9. If it is increasing at a rate, that's a derivative. So theta is changing. d theta dt is pi over 9 radians per minute. The edges are length of 10, nothing about them changing, so A is a constant. And we want the rate of change of area when the included angle is pi over 5. So going from this formula up here, taking a derivative with respect to time of both sides, dA over dt. Now the half and the a squared are constants, so they can just sit there. And I want d over dt of the thing which is changing on the right hand side, sine theta. Now a squared over 2 is there. Derivative of sine theta is cosine theta, but because I was doing implicit differentiation, I'm taking a derivative of theta with respect to a different variable t, then I have to multiply by d theta dt. Well, a was 10 centimetres squared, don't forget the units. Theta was given as 2 pi over 5 radians, and we were given that the rate of change of this was pi over 9 radians per second. Plug that into your calculator and get the answer, which matches A. Again, I'm not going to show you plugging that into a calculator, you can do that. This is a good one. We have the function sine squared x over 2 and cos squared x over 2. They're drawn for us here. Determine the area of the shaded region. It's not terribly clear, but the shaded region is this part in here. It didn't scan very well. So what did I do? Well, the first thing I did was go to my graphing app. It's a tech active question. I'll change my equation back to that type, and I'll delete my parametric equation. Now I'll enter sine squared x over 2, and just to be on the safe side, I'll put brackets around sine of x over 2 before I apply the squared. So that's definitely sine squared. Yeah. And then I'll put cos squared, do the same thing. Cosine of x over 2. Whoops. And we'll square that one. Now I'll draw that. I can see I've got a graph here that looks pretty much like this one. Now my blue one was the sine squared one, so I've just noted here that this is the sine squared one, and the red one, so I've noted that. I want the area between them, so I can use gsolve, then integral. The definite integral gives the area under a function, and I even have the choice of going intersection here. Now the problem with my view is that I've got lots of intersections, so I'll just hit the right arrow until I get to the one I want for the lower limit. Now I'll hit enter, so it locks it in. Then I'll just hit the right arrow again to select the upper limit, which is the one we're interested in, and I'll hit enter. It shades the thing, and there we go. The lower value, the upper value. The integral has a value of 2. The area between these curves, the shaded bit, is 2. And that's going to be choice C. A beautiful question for a calculator. What do we got on this one? The lengths of a random sample of 5 adult humpback whales are recorded. There they are. So I've made a little note. We had sample size 5. Now, how did I get all of these statistics? I used my calculator, of course. So I will use the statistics app. And I'll just enter these numbers: 14.8, 13.9, 15.0, 14.7, and 14.1. Straight there into list number 1. I'll go to calculations, and I better just check which ones are set. For a one variable list, list 1 is the one with frequencies 1. Perfect. So I'll just go straight to one variable calc. There we go. I've got the mean, the sample mean of 14.5. I've got the sample standard deviation S of 0.4743. I didn't write the 3. And I've got the, well, I don't have a z-score, do I? But I've certainly got n. Now, what do we want to know? The length of the humpback whale is assumed to be normally distributed. Determine the interval estimate for mu, the population mean, using a 90% confidence interval. So here is our formula from the formula sheet. We have the value of S available. We have the value of N available. We just need the Z-score that corresponds to a 90% confidence interval. Well, we can do that in our statistics app. Oopsie. Let's go into the stats app. I should have pressed exit at that stage. And exit. Now let's go for a distribution. Actually, my data is stored in list number 1, yes. The confidence level was 90%, 0.9. Sigma is not 1. Sigma is 0.474. List 1, frequency 1, yes. And execute, see what we get. So the lower, 14.15, there we are. The upper, 14.85, 14.85. There's the mean, there's the standard deviation, there's the number. Perfect. So that's my confidence interval. And which one did that match? That matched option B. Now, of course, you could have used the normal distribution to get the Z-score and then plugged the numbers into the formula. But the calculator has that capacity for you. It saves on typing mistakes. Right, so once again, that was intervals using Z-scores, and it was a 1 sample. And so then my data was in a list. What would happen if I put variable data? Then I put the confidence level, then I get to control these things. So confidence level was 0.9, standard deviation 0.47, etc., etc. And we get the same thing. There they are. Question 9. A company produces car batteries with a mean life of 1250 hours and a standard deviation of 28.98. Now, this type of a statement is referring to the entire population. So that's population mean and standard deviation. The manager checks the mean life of the batteries by taking a sample of 50. She would expect the distribution of the means to be normally distributed with. Okay, well, the mean of the means should match the population, 1250, so we can pretty much immediately rule out A and B because they've got 25. The standard deviation of the means is given by the formula sigma over root n. That's our sigma, that's root n. I'm not going to show you how to plug that into a calculator, and you get the 4.09, so C is the answer. This one, consider the function 2 inverse cosine of x plus 1 over 2. Which of the following best represents the graph of derivative f dashed? That's the trap, isn't it? So many people just plugged that formula into the calculator, and then there was a distractor, of course, ready and waiting for you to do that. So let's take a look on our graphing app. So we'll take away these ones from before, and I need to be putting first this function 2 by the inverse cosine of x plus 1 over 2. Now I'll just draw that, and we can see here this first choice here, see how it looks, it intercepts at 2, which would be here. So that's the trap. People are just going to go for this one and not realise that it's a derivative. Now, do I need to take the derivative of this? No, I don't. It's a tech active question. I can go down here to function 2, and I can go options, calculations, derivative, first derivative. And what do I want for the derivative? I want derivative of function y1. Do I want this evaluated at a certain spot? No, I want all values, all allowable values of x, and I draw that. See the red graph? The red graph is my derivative. Now, which of these looks a bit like this one? So that's what I did. I plotted the function on the calculator. I used, looks like I did the trace function, but that's a better way. Use the calculator to do the derivative for you, and then it matches nicely. And that's that. Now, how did I do for time? Well, 23 minutes. Obviously, I was talking far too much. You won't have anywhere near 23 minutes to do these. So the idea, speed and accuracy, practice, practice, practice. Thanks for watching.